All right, let's get started. My name is Josh, and I'm going to be talking you through how to build combat robots using cardboard. So here are some examples of how you could build that. This one has a spinning weapon up in front that kicks the other robot out of the arena. And this robot is more of a wrestling robot. It pushes really hard with a wedge. So it gets up under the other robot and can flip it over and disable it that way without destroying it. But these things do end up becoming dangerous, but I'll talk you through how to do it safely at each step of the way. So on our way to building this, I have a kit to show you to build simpler versions so that as we learn, we have a good way to start. Um, if you're looking at the table now, you're going to see all these parts and you're going to know what each one does. The center of the show is the circuit board. You could call this the motherboard. It's where we put all these little parts in order to make the robot work. So when you're looking at this one, this part is a little brain called an Arduino. It has a USB plug inside, and it also has a little microcontroller, and that runs code to control the robot. This is going to get soldered onto this. You're going to learn that word soldering. This is another part that controls the motors. This allows the brain of the robot to control these motors to spin the wheels, which are attached to this motor. So when you look at this, you end up with two motors and two wheels. You end up with a motor controller that controls the motors. You end up with a microcontroller, which runs the code on motherboard to attach them. There's a receiver. This is the thing inside the robot that controls what the robot is doing. And then on the outside is the controller for the robot. Generally, when I pull the trigger on this transmitter, the robot's going to drive forward. So I drive forward, I go backwards. I can also steer with this knob. So steer, steer. Generally, that's how you do it. And for robots that have an active weapon system, like Fidget here, to spin that weapon in the front, I hit this button right here, weapon on, weapon off. So there are three different things you can do with this transmitter, making it a three-channel transmitter: steering, throttle, and weapon. So the wires that come with it, there's actually quite a lot of wiring here to do. There's the wiring that takes the battery and plugs it into the rest of the robot. And so that's the battery plug. So we have to do that. And then there's the wires that go from the motherboard to the motors. So the motors can get electrical power. So battery can turn the motors by itself, but it's not as controllable unless you use our robot controller that we're going to build. There's some plugs of different types down here. These are called headers. Headers are cool because they receive the pins of the male headers. So you have female headers and male headers. So those click together. It's a lot like Lego, but it's electrical instead of just physical like with Lego. Let's go into a different view and start soldering. What soldering is taking a very hot tool called a soldering iron and taking a very soft, easily meltable metal called solder and melting the two together. And as you melt these metals together, you can add them to wiring to attach the wires to something else. And that is the basics of soldering. I'll give you more details on that in a second. So let's clean all this off so they're only doing one thing at a time. I am going to build the motor controller or robot controller first. So we're going to take this motherboard. It has an upside and a downside. The downside has a lot of this light colored green on it, and the upside has the word USB on it. That writing there that says USB is so you know how to attach this. It ends up going on just like that. Clicks into place. You might think we just solder that or attach it directly like this, but I like to use these special plugs called headers so that you can remove it in case a part is damaged in fighting, or a better part comes along and you want to try that. Maybe put more computer power in it or something. So being able to unplug and plug is actually a very good thing when you make robots, or any other project, really. So let's clear this off to just this stuff right here. A lot of dead air. See, this gold thing here is a way to clean the iron off. So the iron gets kind of rusty on the end while it's sitting there. You can clean it off nice with this. It's a good idea to clean between soldering jobs. So if you look closely at these, they actually have letters on them. For this one, this is board revision 2. Board revision 2 has four different types of headers. It has an A header, two B headers, one C header, and one D header. Don't know if you can see those numbers. But the idea is you have to put them in the right order. If I start with the A header drops into the first long row of holes on the motherboard. I'm going to do that right now. And you'll see it clicks together. Well, it's supposed to click together. Ah, there it goes. It's all clicked together now. You'll see these little wires poking out of the bottom of the board right there. We'll see if we can get a better camera view of that. There we go. I think that shows what we're doing a little bit better. You can see that there's actually wires sticking out of the bottom of the board, and that's what we're going to apply solder to. So the way to solder pins together, a little tricky to see, so I'll try it from different camera angles. I'm cleaning off my soldering iron, and then I'm putting the solder on the pin that I want to solder. Then I'm going to heat the pin and the motherboard at the same time for a few seconds, like 3. Then I'm just going to stick the solder on there, 1, 2, and then lift up. And what you might notice is that now there's metal melted onto that pin and the board. That glues the board and the metal together. So now there's a good joint to let electricity go through that header, through the hole in the top, all the way to the bottom of the board. Let's go ahead and do that for all those pins. This is a little tedious, but you could put on music while you do it. There's no reason to just have constant quiet while you do such things. I'll just go one at a time here. I'm going to heat the second pin and the board attached to that pin, and then dip a little solder into that joint. When I see it melt, I pull the solder away, and then I lift the soldering gun away. Take a look. Take a look. Now there's metal melted on the second pin. Focus. There we go. You don't want to get metal stuck between two pins. Let me show you what that looks like. If I put a lot of solder on here, solder again is this soft metal that I'm using to glue everything together right now. Let's say I put a whole lot on this pin. Get on there. Oh yeah, lots of solder. Look at that. Oh my goodness. Now you end up with this. It's kind of sloppy. See how the metal connects two of the pins on there? That is very bad. That is called a solder bridge. And that will actually break the robot. So you don't want to end up with solder bridges. Solder bridges break robots. So don't do that. The way to get rid of that is just run the iron over it a few times after you cleaned it off. Let's see if I can do that on camera. There we go. Oh, that's so awkward to do backwards. Oh God. Just gonna heat it up and pull off. Look at that. Now they're not stuck together anymore. So now I'm gonna keep doing this all the way down this row until they all have a little metal melted on there called solder, and the pin and the motherboard both have solder on them. You can think of this as like glue holding on the electrical parts. Let's see how we're doing. There's probably a better way to see that. There you go. Now each of those pins has some metal on it, melted, and it's stuck to the board nice and good. These other rows next to it also get those parts, except they get part type B. So I got part type B, and I'm going to stick it in right next to that one. There it goes, drops right in. But it's not attached yet. I still have to add solder to the bottom. So let's go ahead and do that. An easy way to do that is to rest it on the table, grab a little solder with the soldering gun, or soldering iron, just melt a little bit of solder onto the first pin. Let's see if we can do that. I'm going to hold it with the soldering iron. Just drop that in place. This is going to give you one pin. The first pin has a little solder on it. None of the other ones do. But when it's like that, it's really easy to bend the second one into position if it's not quite lined up right. And I think it's actually in pretty good shape as is. I'm not going to bend it or anything. I'm just going to solder it in place. So let's go ahead and do that. I'm heating up the pin and the board at the same time. The holes that you push the pins through on this board have a very special name. They are called vias, as in the circuit goes through the circuit board via a hole called a via. This one right here takes a while to heat up, but once it does, it works just like the others, and you end up with some solder on it. So you can see it's actually pretty fast once you get started, once you get a knack for it. You don't have to rush it. In fact, I did that one so fast that it actually got sloppy. Sometimes when you go really fast, you end up with sloppy work. So take your time on this. If you do a good job soldering, it makes your robot more reliable. And you want reliable robots, especially if you're going to fight them, because then your robot's going to get shaken up. It's going to get hit, punched, knocked around, dropped, thrown around the arena. And so you want reliable robots. See how we're doing. Now all those pins have a little metal on them. And that means they're holding onto the circuit board really tight. I'm done with the whole row. I'm going to do the next row now, which is also type B, not A, type B. Type A will fit, but you can't put a type B in the first row. So it's a little, you can see it's a little loose there. So I got to hold it up straight when I turn it upside down and put it down on the board. I clean the end. I'm going to grab the first pin. Actually, I'll grab a middle pin. It actually doesn't matter. I'm just going to put a little solder on it. Let's see if I can make that pin straight up and down. And I let it cool down. I let that soft metal, the solder, I let it cool down until it hardens back into its metal solid state, like butter. And take a look at that. Look, that's not bad. That's pretty straight up and down, but I am going to bend it over just a little bit. Makes me more comfortable to see it over just slightly. And I can see it's actually not straight up and down, so I'm moving it out a little bit. So now it's time to solder all the way down. So we did the first two rows, starting with the A row, the A, and then we put in B, and then we're going to finish soldering the other B. And in the end, we'll have all three of those soldered down. So I take my solder, very soft metal. I take my soldering iron, I cleaned it off. I hold down the next pin I want to do, warm it up for a few seconds, then put in a little solder. The smoke that's coming off is from what's called flux. Flux makes the metal very smooth when it melts. It lets it stick to the parts really good. So try not to breathe that smoke. It's good to have a fan on. I definitely have the windows open down here. And there it goes. Getting solder on each of these pins. I'm just going to reheat a few just to make it look good, make them look even. And be careful about putting a lot of solder on there, because if you do, you could stick two pins together like I did when I started this demo. And just do a little reheat, we'll clean up. Cleaning stuff as you go is always easier than trying to clean up at the end of the job. So that is 3 headers ready to go. Now let's do the last 2 headers. There's a C header and a shorter D header. And you'll see about these two guys, the C header has an arrow on it. And it's very important to make the arrow point this way on the board. Let me see if I can show that. You see the arrow, right? Arrow. The arrow has to point to the side of the board over here. So the one that says V plus G and D, you got to point towards that. So that's where the arrow goes. It goes the same direction as the label that says USB right there. So I'm going to pop that in. It won't fit in the other way. So that's in place. I do the exact same thing I've been doing so far. I solder one pin by holding it down till it gets hot and feed a little bit of solder into it. And then I look and see if it's straight up and down like the other ones. And it's pretty good. I would bend it over just a little bit, and that looks like it's really nice. So those are looking nice and straight. Let's do the rest of the pins. I'll do one on the end here. The one on the end takes a long time to heat up, so you have to give it a few seconds before you can add solder. And it's good. It's working. Going up the row, adding solder. This pin also takes a long time to heat. Whenever you get a bunch of solder dangling off like a big drop on the end of the soldering iron like this, it's a good time to clean it off in your iron cleaner. Sometimes these come with a sponge and you use a sponge to clean it off, but you have to make sure your sponge is good and wet. So now the C header is installed right along next to the other guys. You can see that right there. Very clean. And when I look really close with the camera, it doesn't look that nice, but it actually is soldered on there pretty good. I'm going to pull just a little solder off of the last pin. Just that looks kind of sloppy. So I'm going to heat it up real good again. Heat up, heat up, heat up, heat up. And add the solder. After a few seconds, I lift the iron up. Oh, that's way better. I'm glad I did that. That looks much nicer. So that leaves the D, the shortest of these headers. D. So I'm going to stick D in the last row. There it goes. I'm going to do the same thing. I'm going to hold it while I turn it upside down. Put it on my board. I'm going to solder one pin. And see if it's straight up and down. That looks pretty good. Now I can do all the other pins. These take a long time to heat up, so you gotta hold it down and just let it sit there for a few seconds while it heats up, really melts together. Let it heat up. So there's no bridges between them, but they're all soldered down. Now all the headers are on. So it's actually on purpose that this one's longer than this one. It's okay, it's part of the plan. Now we're going to add the plugs that go in here and here. These are special types of plugs called screw terminals. And how they work is you put wires in one end, and then to tighten them down, you use a screwdriver to tighten them up. Some of these kits have green ones. The only difference is this uses a Phillips head or crosshead screwdriver, and this uses a flathead screwdriver to tighten. But they both work the same. They're both the same product. Just depends on whichever one was in stock that day. So I'm going to attach the one on top, which is how we plug our battery into the motherboard. You want to plug it with the holes for the wires facing outward. This is on the end of the board, like that. If you can't see the wires from the outside, you put it on backwards. And what that would look like is this. That's backwards. Now I can't plug my battery into it. So I have to twist it around front ways. These are big pins, and all the power of the robot flows through this part. So that means it's going to take a while to heat it up and stick solder on it. But I can try. So I'm holding this against the pin, those big pins there, big pin, and also against the board, letting it heat up for 2 or 3 seconds, and then touching the solder to it. Oh, there it goes. Let that melt together, and then I lift the iron up and off. And I left a little too much solder on that, so up and off again. And now there's solder on one of the sides. Actually is kind of sloppy still. Hold on. I'll figure that out later. I don't know what I did wrong. But we can always heat the next one up. That looks better. So now we have a place to plug our battery in. But if I plug a battery into this, it's not really going to do anything. There's nothing on here that does any work. We still have to put some more terminals on there, terminal blocks. But these last ones are special. When you line them up so they have their holes on the same side, they have a little edge. And that edge actually slides into each other. Man, this is hard to watch, hard to see, but these actually slide together. So I take this one on top of that one and slide together. So you can see them starting to slide together, but they're stuck together now. And then I push them all the way so that they're one piece now. So it's almost like Lego. They have to be pushed together to fit in the board. So it makes a 4-wide terminal block. And again, you have to face it out like that. Look underneath, you can see the 4 big pins sticking out right here. And we have to solder all those. You can see them down here. So we are going to solder those. They're big pins, so they take a lot of heat. So it's okay to give it, a good 5 to 10 seconds to warm up. Good 5 to 10 seconds on each of them. It takes a while. Not a whole minute, just 5 to 10 seconds. When it's hot enough, the solder will melt against it. So that's the outer two. Let's do the middle ones now. Those are all soldered on beautifully. So now the motherboard is completed. It doesn't have any parts on it yet, except those little connectors. But that is the whole motherboard step. Now we have to find a way to attach these parts to the motherboard. And these are female headers or female sockets. These are male pins. So what I'm going to do is I'm going to plug the male sockets into the two B rows. Remember the two B-type rows? So look at that. Look at that. I plugged them right in there. They just fit perfectly. Watch out that you don't do this. I'm not sure how to show you that, but anyways, make sure there's a pin in every hole. You don't want to have it hanging over the side. And what's fun about this, see that label that says USB right here? Well, it turns out I have a USB board right here, the microcontroller or Arduino. And this should fit right on top of the male pin sticking up. Look at that. So those male pins are still in their sockets, but the tops of them poked up through the circuit board that has the brain on it. And now we're going to solder those pins on. Make sure that the USB port on this one's USB-C and it's on the USB side of the circuit board. Because I did one upside down one time and it didn't work right. There's no USB down there. It has to be plugged into this side. So let's finish that up. I'm going to add solder to each of those pins. This design doesn't actually use all of these. I could get away with not soldering every pin, but most of them are needed. Most of them are needed in the design. Some of them control the motors, and some of them are connected to the radio receiver, so it's able to be remote controlled. I'm just reheating each of them to make sure they're clean and cleaning off my iron every once in a while. That's how you get the dirt off. So it can get a little messy when you're doing circuits, when you're doing soldering. Let's see how we're doing. I think we have all those soldered on there pretty good. You see how this side has solder on it, so the pins have kind of a kind of cone shape now. And the ones on this side are still straight because they don't have any solder holding them on. So we have to add solder to make the circuit complete. So let's try that on the other side. We'll use the overhead camera, give you a different angle. Again, I'm just holding down the iron to one of the pins and the motherboard here until they warm up, and then sticking the solder into it. I'm going to turn this to make it a little easier to get where I need to go. There's actually, I already made a mistake, but we'll go back and fix it in a minute. Because I didn't clean off my my iron enough, I've actually created a problem. Check it out. Right there. Two of the pins are actually stuck to each other. And that is a broken robot. I have to fix that. So what I do is I clean off my soldering iron and I just reheat the two pins. There they are, right there. So I'm going to reheat the pins and lift up, clean off my soldering iron, reheat the pins, lift up, clean off the soldering iron, and now none of the pins are stuck to each other. They're all lined up and they're all soldered. Let me show you the magic of that, why we did all that trouble just to attach this to the circuit board. It's right here. If you're in a robot fight and this breaks because it's fragile, it's the brain of the robot and it breaks because a weapon hits it or catches on fire or breaks or even a new one comes out and you want to upgrade, you don't have to throw away the whole robot brain. All you have to do is grab this part and pull it off. And now this is removable. So now you can put it back together by lining up all the holes and pushing it back together. And so now you have a upgradable or replaceable brain on your robot controller. Let's do the same job with this that we did on that. So we're not gonna solder this directly to the board. We're gonna use sockets, and we're gonna use male pin headers to make this happen. So if I look at D, the one on the end, it's the shortest of the headers. I have a set of short male headers I'm gonna plug in there. And I have another one just like it. And I'm gonna plug them in. This, you have to pay attention to this. This has to line up with that. So again, see how these pins are down here? This other one has to line up with that one. So like this. So leave these other three holes alone. They're supposed to be open for now. I pop that in. And now those pins are in. And now we're going to take this guy. This is the thing that controls the motors. So this by itself is not powerful enough to control motors, but this is. That's its whole job. You actually flip it upside down so that you can't see those black parts or orange parts. You flip it down and then you put it on these pins right here until it drops into place. And you look at the writing on the back and look for one that says PWM. The PWM one goes towards the microcontroller. So I pop that on here. And if you get this upside down, it's fine. You just have to flip it right side up. Let's look at that. So the one that says PWM points towards here. And the one that says AO0 and AO2 points off the edge of the board. So there you go. It's ready to get soldered. Since I'm right-handed, I like the thing to solder to be on the right side. And if I have a row of holes to solder, I like to have them away from me and towards me. Not like this. Trying to work like this is very awkward. Trying to work like this feels more natural to me. So I heat the pen and I heat the board and then melt some solder on that joint. Wait for it to heat and melt together and I lift straight up. Let's continue that until all the pins are done. Some of these pens take a long time to warm up. That's okay. Just give it a few seconds. Maybe rub the iron a little bit. Sometimes the iron is dirty, so you have to have the iron on there longer to do the same work. Heat together and then lift up and away. Make sure they're not stuck together. Make sure there's no two pens that are glued together. So those are all independently soldered down. Now it's time to do the final row, which will actually finish the brain for the robot. This is a motor controller. It's the brain. And this is kind of the smart part of the robot. It's not the muscles, it's the smarts. But to fight, you gotta have smarts and muscles. You gotta hit smart and defend yourself smart. Want it to be a good sport with action and winning and losing gracefully if you have to lose. So it's good to have muscles and smarts. That is a completed motor controller. This is a BoxBots Type 2 controller. You can tell, well, I can describe it later, but when you're looking at this, um, the Type 0 was brown, the Type 1 was white, and this is a Type 2. And we're not done upgrading this thing. We may have to go upgrade with a different geometry, but for now, all the pins are in place. Hello, I'm Josh again, and we're going to be working on the cardboard-based robots. Cardboard-based combat robots. Some of them just have a ramp that they can scoop the other guy out of the arena with, and that's what this one does. And some of them have an active weapon, like this one chews up the front of the robot and can throw him over. Last time we built the brains for the robot. This is what takes the controls from the radio receiver and translates them into motion of the motors so you can drive around or control the weapon. But there's no connection between these two right now. There's nowhere to plug the motors into the board. We need to add wires and use that to plug these together. So I'm going to talk about doing that. On the end of this motor, there are two terminals on it, right here on each side of here. So here and here. And those right there are going to receive the ends of wires. The kit comes with wires. with black and red. So those are pretty cool. Let's see. So I'm going to start adding those together right now. Let's do the overhead. There we go. So I grab just one set of wires and one motor, and I add a little solder to my iron to tin it, or add tin to it. Tin is a metal that melts really low temperature. And I warm up that terminal, warm up that wire all at the same time, and then lift the iron out of the way and let that harden. And now something wonderful has happened. The wire is now soldered and connected to the motor, but it takes two wires to make the motor spin around. So I'm going to solder the other side now. I put the red on, so I add a little solder there. And well, it's a little awkward, so I'm going to use tweezers to hold that together. And I hold it together for a few seconds so the metals can harden up and get to know each other. And now I can test it. This wire is on there pretty good. This wire is on there pretty good. I like it. I'd say those wires are on pretty good. A thing you can do to really make your robot a lot stronger is after you get the wires soldered on, is add some glue to the ends of the wires right there so that the wire and the motor are stuck together more than just with the solder. Well, let's see if we can do that over here. I have a hot melt glue gun, and a hot melt glue gun is cool because it squirts out plastic instead of glue. And you can use the plastic to stick things together. In this case, we're going to use the plastic coming out to attach the wire on this side to the motor on this side. And go back and forth a little bit all the way around that wire. Look at that. Don't use a whole lot. Just enough to round it out. And I just wet my finger a little bit, spit it there. A little bit of spit on there is good. Just to pat it down and get it all enclosed around that wire. So now the wire is glued on with solder and glue. Let's do the other side real quick. So glue comes out, and then I go on both sides to the wire, to the motor, to the wire, to the motor, to the wire, to the motor, back and forth. And to do a little shaping, I wet my finger with, you could probably have a dish of water instead of, spit, but spit works too. When it's your robot, it doesn't matter. It's got your own germs. So now the wire is glued and soldered on. So that makes it a lot stronger for when robots run into each other and things get pulled and torn from each other. The motor will stay glued to the wire. Let's do that to the other side real quick. So I have the other motor right here. And again, I have the wire. You don't want to use this wire, but you can actually. Just for giggles, I'm going to take the battery wire, the battery plug wire, and attach it to the motor, just to show you what happens when you do that. Just a quick solder job. Doesn't need to be hardened because it's only for a second while I do the demo of what happens when you do this. So now I have a battery plug attached directly to a motor. Let's stick a wheel on there to show you what goes on when this happens. Now this right here could actually drive by itself. You don't even need the brain or the radio receiver to do it. So what I'm going to do is I'm going to plug this in. What do you think will happen to the wheel when I plug this in? Let's find out. Plugging it in. Look at it go! It doesn't go anywhere because it doesn't have a robot body, but it also doesn't stop either. This is a very silly robot, but it would move around, but I think it needs the brain to make it a lot smarter. So let's go ahead and unplug that now. When I unplug, I always grab the body of the plug right there, and then the body of the socket and pull them apart. Don't just yank on the wires. Grab the plugs and pull them apart. So now, let me unsolder this. So I'm going to take this wire back off. That's the battery wire. So what I really want to use is the wire that just has ends like this. Let's see. So I did the black wire on this side on the other motor. I like to do the same thing on both sides. Pull a lot of heat and wait for it to solder, wait for it to get solid before moving on to the other side. Ooh, that's too hot for me to hold with my fingertips, so I'm going to grab my tweezers and hold it still until the metal becomes solid again. It only takes a few seconds. I am going to add just a little bit more solder here. Just a tiny bit more. You probably won't have to do this at home. The only reason I need to is because I'm reusing this motor for this demo. Oh, that looks a lot better. That looks a lot better. I like that better. And we're going to add some hot glue again to make that more solid. So we have the electrical connection complete, but let's do a mechanical connection. Back and forth a few times between the wire and the motor body. Do the other side, back and forth a few times. Do the underside too. Back and forth, back and forth. Just let that hot melt glue solidify and go back to what it used to be. Because the hot melt glue starts out as a stick of plastic that it melts, and then you use the glue. Here's a stick right here of the plastic glue sticks. That's going to take a minute. I'm wetting my finger a little bit to do some shaping last minute. And now the wires are mounted to the motors. Let me pull that wheel off. So now we have two motors that are ready to attach to the body here to make a robot. Let's see what that looks like. We're going to take the holes for the motor connectors. The motor connectors are the four wide ones right here. So we're going to stick the wires in these holes and then use a screwdriver in these slots up here in the screws to tighten them up and make the wire stick. So the key here, let me see if we got a better view over there. Let's see. Hmm. Ah. Hmm. Hmm. All right. So here comes a motor. I'm going to grab, I don't know, let's grab the black wire first. I'm going to stick it in the hole, and I'm going to turn the top. I don't know, let's do the red one first, towards me, and then turn the screwdriver to tighten onto the wire. For this, it's nice to have help to hold the board down when you tighten. You don't have to get your whole fist around it, but give it a good tighten with your fingers. And make sure that when you're done tightening, that the one you just tightened doesn't come out really easily. I like to use tweezers to put in the next one so you can line it up with the hole. So now both wires are in their holes. And let's do the screw thing again. Tighten it with my fingers. I don't have to get my whole fist around there and tighten. Just my fingers. I make sure that the black wire doesn't come out. Good. I make sure the red wire doesn't come out. Good. You can tell it's tightened too because look, when you tighten them, they sink down in while they pinch the wires inside the sockets. Well, looks pretty good. I'm ready to move on to the other motor. It's important to not have the battery plugged in for this part. Don't want the robot to start driving away from you while you're trying to put it together. So I want the exposed metal end of the wire to go in, but I don't want the rubber part of the wire to go in. Clamp down on that bare metal. Fingery tight, not hand tight, just fingery tight. There we go. Make sure the wire doesn't come out when you pull on it. Good deal. I'm going to grab the red one, stick that in too. Sometimes you have to do this more than one time to get right. Once you get some practice at it, it's really easy. In version 3, I don't think we're even going to use these screw terminals anymore with the screwdriver. I think we're just going to use plugs that you can plug in and out with no tools. Let's see what we got here. Okay. Very good. I'm suspicious of the red one here. I'm going to redo it. I'm suspicious. I don't like it. And yeah, that's what I thought. I clamped down on the rubber part instead of the metal part. There we go. So now we have motors, right? We also have a robot controller. Now, the motors need to be told which way to go. The brain over here is not set up to tell them what to do on its own. So to do that, we're going to need different wires. We're going to need a remote control receiver, a remote control transmitter, and these funny little wires here. The wires are fun. They're called jumpers because they jump from one part of the circuit to another part of the circuit. And these ones have a female side and a male side. So I'm going to take my darkest one here. There should be four. The darkest one I have is brown. You might have black or red or blue. I've got brown. And brown is going to go into the receiver. So where I'm going to put it is there's the box of the receiver, and you'll see there's pins over here on this side, all the way this side towards this edge. Any of those four pins over here, you can plug it in. I'm going to plug it in towards me at the bottom. Take a look at that. So that's where I plugged my brown in. I've got an orange, or sorry, I got a yellow here. So I'm going to take the female side of the yellow and I'm going to plug it in right next to the brown one. So they're forming a row there, a row this way. So there's brown and yellow, or dark and light. And what those are is the negative and positive power supply for the receiver. So that's a good start. I'm going to take this third color and make a complete row of three across the top. So my final color in that row, I picked orange. So that's the final color. And then I'm going to put this other yellow one. Gosh, that's hard to see. Let's do the other one. So there's the row. I have the dark one all the way towards the edge here. Any of those pins on the edge, you can plug that into. I have the light colored one right here. I have it plugged in any of the middle ones. Those are all good. Those are all the same. But the special pins are on this side. Each of those pins is different. You can see a label on the sticker that says channel 1, channel 2, channel 3. And channel 1 has this orange guy in it. And I'm going to plug this yellow one in next to it. So he has a little neighbor there. See that? And it's hard to see what I'm doing. When you look at it from this side, you see those two, channel 1, channel 2, are now next to each other, yellow and orange. So now we'll do the overhead here. If you look closely at this board, oh yeah, the other one's way better for this. Look at the board, you're going to see letters and numbers by the pins over here. And what I want you to look for on this side right here is one that says G and D and one that says 5. Let's see if we can find it together. There it is. There's 5 and there's G and D. What I'm going to do is take that brown wire from my receiver, so the brown wire right here. I'm going to plug the brown wire into G and D. It's very important I get this right. So G and D is second from the bottom, G and D. So I plug that in next to G and D. The other one has to go into +5. You can go one hole, skip it, and go to the next hole. And that's how we get +5 into one wire and G and D into the other wire. That's like minus and plus. And if I follow those two wires over to the receiver, I see that one is plugged into the row that's by the edge. Good. So that's G and D. And then the positive one, +5, is plugged into the middle. Because what we're going to do is be taking and finishing the wiring, which will make effectively a robot. Now, it won't have a body or a frame, but everything you need to have a drivable robot will be done in just a few minutes. The next part I want to get into is this right here. It's a very special end on it. You see that? And what this does, it allows you to plug the battery into the robot. So where these wires go is pretty important. When you look at the end, right up here, there's a place for the power cord to plug in, and that's what this is. It's the power cord. Battery plugs in there. The other ends, they're going to plug in right there in the battery. So let's see if I can get that done. So I'm going to line up, there's two sets of text here, V plus and G and D. V plus and G and D. And the V plus is going to get the red wire. So I stick the metal part of the red wire into that hole in the top of that terminal block. When it goes in there, I tighten the screwdriver. On top of it, you can go pretty tight, just finger tight, not arm tight, just finger tight. And I test the wire. Boop, boop. It's staying in there. Let's do the same for the black one real quick. Stick the black one in the hole. Screw the top together. I give it a little tug to make sure it's staying in there. What you can do at this point to test that the robot brain's actually going to work is I'm going to plug the battery into it. The plug can only go one way. If you try to put it in backwards, it just doesn't go. Doesn't go, and this way does go. When I plug in, I see some lights start blinking at me. I also see that because I applied power from this board with these two wires into the receiver starts blinking. I'm going to take my transmitter, though, little gun-shaped thing here. I'm going to push the on button. Now watch what happens to that blinky light now. Oh, it's steady. It's steady because now this and that transmitter can see each other, and now they're bound to each other. Turn that off again. It starts to blink. Turn this back on. So that means they're connected. So this test right now shows me that the battery can power the brain inside here. And the really fast blinky light right here lets me know that the code that that you can use as a starter for your box spot is already downloaded. If it blinks slowly, that means you have to see my other video on how to program it with the box spot code to get started. Anyhow, now that we know the power is good, I'm going to go ahead and unplug this thing. So always grab the plastic parts here to pull. Don't pull with the wires. Pull right here. And now the light went out. The power is off. I can set the battery aside now. Let's see what we got here. We're in good shape. It's time to put the last two wires in place. Let's see if we can go with the overhead on this one. The last two wires are channel 1 and 2. And channel 1 on this build is orange. Yours might be a different color, but we plug the orange one into channel 1. It goes in these 3 holes up here. It goes into the first hole. Right there. Let's get that close to the camera, you can see what's going on. See how it's in the first of those extra 3 holes? Now there's only 2 extra holes, and guess what I do with the other one? You got it. You plug it in next to the other one. Very simple. So now all of the wires are plugged in. We've got wheels, and those stick on like Legos. You just push them on the little pegs that come out of the motors. Look at that. So now we have wheels, we have motors, we have wires, we have a battery, we have a transmitter. Let's turn the transmitter on. The lights are on, now it's ready. And now I'm going to plug in the robot and see what happens. Ooh, we got a live one. Let's see where my problem is. Hold on. Ooh, it's not that one. There it is. I'll teach you guys how to do what I just did, but now that these things are still, let's see what happens when I pull the trigger on the remote control. Ooh, the wheels are turning. They turn that way when I pull it, and then they turn the other way when I push the trigger. Pull, push, pull, push. Look at that. Let's see what happens when they do with this other wheel here, the steering wheel. Well, then they go the same direction. Interesting. Well, next time, we're going to make a very basic robot body. And we're going to turn this little assemblage of parts here into an actual running vehicle. So I can't wait. I think that's a good place to stop the video because we have an assembled robot here. And the last thing you do before you stop work or stop playing with your robot is you make sure you turn it off. And for this one, you turn it off by unplugging the battery. Light goes off, and then you turn off the transmitter. So when we come back, we're going to build the most basic robot body. I'm telling you, it's going to be basic. And it's going to look silly, but it will actually work, and we'll be able to drive this thing for the first time. So I'm looking forward to that. I'll see you guys soon. All right, welcome back. Last time we were together, we got the wiring completed, and we actually drove this around using this remote control. And on our way to building a more dangerous box spot, like Fidget. Like Fidget has a spinning motor that can cut through a 2x4. It's very scary. We're going to build the most basic type of robot. And the materials we're going to use are the wiring that we completed so far, which every box spot has. Even Fidget has the same stuff inside it. It has motors, it has that brain, it has this battery, it has that receiver. So same stuff inside. But we're going to start simple with a piece of cardboard. So what I'm going to do is move everything up, focus on this, the piece of cardboard. And what we're going to do, the robot needs to be 8 inches, it needs to fit in an 8-inch by 8-inch box. So to get there, because this piece of cardboard is like, I don't know, 10 or 12 inches on the side. So I'm going to cut off that much, and I have a ruler here so I can go 8. We'll go across, making about a square. 8. And then we'll draw a line over here. I'm going to cut out this square right here. Maybe you can't see it on the camera. So let's do something a little bit more dramatic. I'm going to do this square. This is an 8-inch square. And just so you know how big that is, that's an 8-inch square next to my head. And you'll see robots like Fidget fit in the 8-inch square. So 8-inch square. So let's take a look at what we can do with this 8-inch square. To make this first one super easy, I'm going to take my box cutter and my steel straight edge, and I'm going to make an 8-inch square just by cutting this free of the rest of the cardboard. I'm going to keep that cardboard though that I'm cutting away because it can be very useful later to make shapes. But for now, 8-inch by 8-inch cube, or 8-inch by 8-inch square. I'm going to put the wheels, I'll put them right about there. And the brains about there. And the battery, I'm going to put between the wheels. So let's see what that would look like. To make it easy to sketch, I'm going to use the light blue pen. So here's my wheel. So that's how big the wheel is from right above, right? Tracing out that wheel. And then let's see how big that motor is. The motor is going to be about that big. There we go. So there's the motor and the wheel. And I'm going to follow this line sticking out of that other motor to help line up the other side. Now let's see how we're doing. I think we have enough to finish our design. So if this is the size of the wheel, and I want to put the wheel through this cardboard, I don't want it floating on top of the cardboard. I want to put it through. So that means if I cut these out, the wheel will get kind of stuck on the edges. So I need to make this hole just a little bit bigger. Just a little bit bigger than the wheel itself. Just a little bit bigger. So it doesn't drag on the sides. If you look at a wheel on a car, does it go right up against the walls of the car? No. It actually has a space so the wheel can move freely. So I'm just cutting this out. Notice I'm always cutting away from my hand. And I'm not trying to cut like this. I'm trying to cut pulling with my whole arm. So I'm actually pulling from my shoulder. It's kind of hard to see what I'm doing from above, but that means I have an 8-inch by 8-inch square, and the wheels can fit through those holes and have room to spin freely. So let's go ahead and attach those motors. I'm going to use a special type of glue called hot melt glue. Hot melt glue goes into a pistol shape like this, and when you pull the trigger, hot glue comes right out. It's just plastic. It starts out as a stick like this, and the heat of the pistol makes it into a liquid. And then when the liquid is completely cold, it goes back to a solid. So I can fold that over, and now those two pieces are going to be stuck together once I let it cool down a little bit. Let's give it 10 more seconds. Now it's folded together and stuck because of the hot glue. So now we know how the hot glue works. I'm just going to attach the motor by giving it some hot glue on the bottom, like this. all the way up the yellow part on the flat at the bottom. And then I try to center the wheel so that it's lined up with the side and also is lined up front to back so it's not twisted out or anything like that. But we're going to do the same thing I did over there. I'm going to add a bunch of glue on the bottom. Blop, 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 blop on the yellow part. And I'm going to rest it on the cardboard so the edge of the yellow thing matches the edge of the cardboard and the tire is kind of centered in that hole we made for it. Yeah. And this part is a little patience, but you got to hold it still for a while. It's your last chance while it dries to line up with the other one. So it's not too wonky. You don't want wonky robots. When it's wonky, it makes it harder to steer and it doesn't push as harder. It doesn't push as hard. Excuse me. Hot glue gives you these little strings. I don't know if you can see them, like hairs. You can just pull them off. They don't hurt anything, but they also don't look very good. Makes your robot look a little unfinished. So I'm thinking the battery should be here. So to keep it there, I'm going to fold this in an angle. All I'm doing is making a little angle out of cardboard and gluing it down to the base. I didn't mean to glue that to the battery. Oops. You can just rub that off. Hot glue doesn't hurt it. So let's just let that harden for a sec. Nice. I'm going to fold this one in half too, just to make a corner. Let's see here. Something like about there, I think is the right place to put this. When you're doing this, you're probably going to redesign it like 10 times. So it's okay if you don't add a lot of glue. I'm just going to hold it down there for a sec, just to let it cool. I want to pull the battery out of there before the battery gets stuck to the glue. All right, so it looks like that's holding down. Remember, I have extra material over here. I'm going to grab that much. Let's see where we can put this stuff. I'm thinking right there. Okay, be up soon. That's a good position for the guts of the robot, the brains and stuff like that. It looks like that's going to be too much. Before I set it down, I'm going to cut that off and go like this. Just let that harden. And while it's hardening, let's position this wiring and stuff over a little bit. And it looks like we're going to need just a little angle around the end. Maybe not as big of an L shape, like that. Let's see how that fits before we put glue on it. Oh yeah, that'll hold on nice. So, alrighty. So I'm just going to hold this down and see. I'm just doing really rough shapes here. I'm not trying to make anything very specific right now. I'm just trying to get some basic protection for the robot's wires and to hold this stuff in place. And now I'm going to put this inside the battery. I can power up the robot by turning on the remote control first. And while that's on, I plug the battery in. It only goes in one way. The blinky lights are a good sign that things are happening the way we want. All right. Now I'm going to drive forward by pulling the trigger. Oh, it's backwards. So I'm going to switch the throttle direction. There we go. I drive forward by pulling the trigger. And when I push the trigger away from me, it drives backwards. Pull, push. I'm going to rotate the steering wheel. I'm going to try it the other way. Hmm. 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 Yeah, that's the way I like it. There we go. So now we have a very basic chassis, a frame that holds all the stuff together. And if you wanted to, you could slap one piece of cardboard over the top of this, and now you have a fully enclosed set of electronics. You could start from this basic form and build all the way up to something a bit more advanced. Aw, Fidget's upside down. There we go. Now Fidget's in the party. And if you really pay attention to class, and you stick with the program long enough, and you pay attention to safety procedures close enough, you might get to play with something like this. A chainsaw bot. But for now, let's keep it simple. It's light, it's fast, very mobile, and it's ready to receive all kinds of upgrades that your heart may desire. So I think we have a pretty good start here. And we have a pathway to go forward and build more and more complex robots. Remember, when you turn it off, you grab the battery wires, and you grab the little plug that is on the end of the battery wires, and you pull on the plug, not the wires, just the plug. There we go. So the battery's out, and then the remote control is off. So now the robot is safe, and with it unplugged, it becomes safe to work on it again and make changes as you see fit. So I know it's not the same thing as getting to build Fidget, but to build Fidget, you have to be able to build this and make improvements on it until you get to the point where it's fighting the way you want and powerfully as you want. Also, the most important thing about this design is it allows you to learn how to drive. The skill of driving well against another driver puts you ahead of most people who try to play in this activity. Knowing how to drive well is how you win matches that are actually competitive. Because I could have the worst weapon you've ever seen or driven against, but if you can outdrive it, if you can outdrive me, my weapon means nothing. And you could actually disable me or use my weapon against myself. So anyhow, start slow, start small, and build up from that. And that's a good beginning. Thank you.